Okay, let's talk about transformers. This is a schematic diagram for a transformer. Transformer is some iron with windings on it, and it induces a magnetic field. So the electricity gets turned into magnetism, the magnetism gets turned back into electricity. So anyway, this is what this transformer that I've just built has in it. It's got primary windings, which are on the left side usually, and secondary windings, which are on the right side, but could be either way. So this is a transformer that allows you to do either 110 volts or 220 volts. So this winding is a 110 volt winding, and this winding is a 110 volt winding. So if you put a short here and you connect your wires to the outlet here, it acts, the transformer will act the way it should for 220 volts. You have these both in series. And if you want to use it as 110 volts, then what you need to do is you need to not connect these two, but you need to connect these two, and you need to connect these two. And they sometimes denote this in a diagram with some dots that tell you how the winding is done on the core. So if it's a right-hand winding, you want to continue as a right-hand winding. You don't want to turn it upside down and have it go the opposite direction, because one will create a magnetic field in one direction and one will create a magnetic field in the other direction. They'll cancel each other out. It'll cause a bunch of heating and current flow and everything, and it'll break your circuit and it'll just cause havoc. So do not do that. So it's really, really important when you get transformers that you wire them up correctly. Now the transformer that I just put in the box was already wired for 110. I already saw the little shorting blocks in there, so it had this, it had two shorting blocks. So it had one shorting block for these windings and one shorting block for these windings, and it was wired for 110. So hope that's not too confusing. What I really wanted to talk about today was the secondary side. So some people know about the primary side. Sometimes the primaries look like this. They'll have a primary that's, say, 120 volt primary. And then they'll also have a tap here that's 100 volts. So if you're in Japan, you'll wire across these two windings. And if you're in the United States, you'll wire across these two windings. And so you might see that, okay? And there'll be a secondary over here. You'll also see it on secondaries. Sometimes there's multiple taps. So maybe this is an 8 volt tap and a 12 volt tap and a 20 volt tap. This is fairly unusual, but it's not uncommon. It's done all the time in power supplies like this, this HY1803. So if you want to build a power supply that goes from 0 to 18 volts at 3 amps, and you're only outputting 3 volts at 3 amps, you've got to get rid of all those extra volts someplace, and so that's very inefficient and causes heating and all kinds of other things. So the way that these work is they have a multiple tap transformer, and so when you're operating those supplies off of low voltages, it has relays in there, and it'll connect the, let's say you've got some type of 3-terminal type regulator thing here, you know, variable regulator. It'll run it off the 8 volt tap, and then as soon as you cross the threshold and you go up past 8 volts, that relay will disconnect the 8 and connect you to the 12, and then this thing operates on 12 volts. And if you go higher up, there's a relay that clicks into the 20. And so you'll hear that thing sometimes click as you move the knob up and down. And so it's a multiple tap secondary. Well, if you have windings like this, a lot of times these transformers will be sold. They'll call this one an 808. So it's a center tap, it's 8 volts across these two, 8 volts across these two. And then this is a 020. So across these two is 20, across these two is 20. And usually these are used like this. And this comes into ground, and then this goes to a capacitor, and you get full wave rectification with just 2 diodes because it's center tapped and everything's great. So that's usually the way they're used. But you don't have to use them that way if you don't want to. You could use 20 and you could use another 20, or you could go from here to here and you could get 40 volts out of it if you want to. Same over here, 0 to 8, or you can get 16 volts if you want to. And what people don't know is if you wire them up right, you could say start here, you get 0 to 8 volts. And if you tie these two together, you can get 28 volts from here to here. 8 plus 20. Or you could go from here to here and you get 40 plus 8, 48. Now the trick is you have to make sure that the windings are all in the same direction, like these dots over here. So you need to test your transformer out and make sure that when you connect these two, you're getting 28 volts and not 12 volts, okay? If you connect these two and you read 12 volts, turn off the power. Hopefully it's not in a circuit and you're not drawing any current, because what happens is if you hook these up backwards and instead of 8 plus 20, you get 20 minus 8, those 8 volts is actually backwards magnetic fields and cancels out the other side and just causes heat and current draw and all kinds of nastiness. So yeah, don't do that. Please don't do that. But you can wire these up if the windings are in the right direction. And you can get all sorts of voltages. You can get 8, you can get 16, you can get 20, you can get 28, you could get 16 plus 20, you could get 36, you could get 40, you could get 48, and you could get 56. So let's do that. All right, here's my box. I have it labeled 808 and 20020. So this is the center tap. These are the two 8 volt secondaries. Here's the center tap for the 20 volt secondaries. And so let's go measure those. Let's get out an accurate voltmeter. How about this one? Okay. So we will set this to AC volts. And it's going to read on the 100 scale. So 0 to 100. Okay, so you read the top scale. That's 20, 40, 60, 80, 100. Okay, so we're just going to use one scale. And here are the clip leads. So let's start on the center tap of the 8. And I will connect it to this side. And you can see that the meters come up here to 8 volts. That first major mark is 10, so it's measuring 8 volts. Let's measure the other tap. It's also measuring 8 volts. Now let's move, so we're going from the outside tap to outside tap. We should get 16 volts. And we do, 16 volts. All right, so now let's move over to the other side. We'll go for a 20 volt. And sure enough, we're getting 20 volts. Now we'll move to the other side. And the other side, we get 20 volts. And if we go across both of them, then we should get 40 volts. A little bit more than 40, because these are a little bit more than 20. So that all works just great. So now let's think about adding these things together. So let's see if we can make 28 volts, okay? We're going to go from the center tap of the 8 volts. This terminal, we would read 8 volts. We can do that. Here's 8 volts, okay? And we're on the center tap of the 20. Now, if we short these, the way that I have this thing phased is I can just short these two together, okay? And everything will work just fine. They'll add, not subtract. So I'm going to connect these two together. And now it's going to measure, well, it's measuring right about 30 volts, so 28. And so then we can go to the other side over here, and that should be 40 plus 8. That should give us 48, or about 50. And we're up here about 50. Okay, And then we could get, let's see, we could go back to 28. We can then add the other 8 volts. So that gives us about 39 volts, something like that. And then if we go all the way across, we can get 16 plus 40. There we go, right up around 60 volts. So we have all of these combinations available to us. That's great. So if you want to use this little box in different ways, you can just wire them up. Now, it's the weakest link in the chain, right? If I don't know what this transformer is rated at, but let's say that the 8 volt windings are rated at 2 amps, and the 20 volt windings are rated at 1 amp. Well, then you're stuck at 1 amp. You can't get any more than 1 amp out of it. It's the lowest current rating of whatever winding you use. Otherwise, if you've got to try to get 2 amps out of it, you'll start heating up windings and burn things up. So, and then if you needed to get in between voltages, like I said, you can put this box on a variac and change the input voltage, change that 110 volts. So let's say that we wanted 41 volts. Okay, let's see here. We could get 40 volts this way. Oh, it's going to be a little bit higher. So let's say we want exactly 50 volts. Okay, so we go to here, and it's just a little bit high of 50. Well, we put that on a variac, and we turn it down just a little bit so we could get to 50 volts. So we can get quite a few voltages out of this thing. And great for designing power supplies, or sometimes circuits you just need an AC signal. And you could have a function generator, and that'll give you an AC signal, but this is like a poor man's version of an AC signal, or you needed 60 hertz for some reason at some high current. The generator's not going to give you high current, but this will. Anyway, I don't know if you knew that trick about adding secondaries together.